Ladies and gentlemen, welcome to our mathematics class. So in this particular class I will be talking about set operations. So when you talk of set operation, basically it is the foundation of mathematics. So whatever we'll be doing, if you ask your colleagues who have registered for Excel tuitions, they'll tell you that when we are dealing with functions, we are still relating our answers towards to sets. So make sure that you follow each and every component that I'm going to teach. If you have any question, you are free to ask. If you have any answer, you are also free to ask. We are a family and let's build each other. So like I have stated, we are simply looking at sets operations. Okay, sets operations. So for me, normally I just go direct to what the examiner wants you to know, what you need to expect in a final exam. Okay, so the first thing that we need to know is to define a set. Okay, so can someone tell me, what do you think a set is? What is a set? What is a set? Just someone to raise their hand. What is the set? Yes, Grace.
A set is any well-defined list or collection of objects called elements or members.
Okay, so when you talk of a set is a group of well-defined elements or members. So a set is a group of well-defined elements or members. For example, if I talk of a set of female 2026 freshers, okay, a set of female 2026 Unza freshers. Okay, so here I'm trying to give an example of a set. Okay. So if I'm talking of a set of female 2026 Unza freshers, so in this set, this is a description. It is well defined and it is specific. Okay, if something is well defined, it has to specify of what it is defining. If you are trying to define who Dr. Possibility is, of course you are going to define that he's the founder of Excel Academy, he's the founder of Let's Make a Difference, he's the founder of Kasombi Test, he's the founder of Excel Farms. So those are things that you are going to define, well defined. So same applies with a set. A set is a well defined collection of what we are calling what? Members. So if I was to pick, maybe I can pick 5 of you randomly, 5 of you. I can start with Grace, who just responded. I'm pretty sure yesterday I heard of a name like Rosemary. Okay, I think in Excel we have someone like Crystal. Who else can I mention here? Louis, Glory, etc. Okay, so in this set it is well defined. We are talking about what? Female. You can't put Joseph or you can't put Augustino here. Why? Because this is a set of well defined elements. Let me talk of another example. I can talk of one of my favorite examples, a set of vowels. Okay, a set of vowels. So in most cases, I normally love this example. In almost all my classes, I've mentioned this. So a set of vowels, you talk of R, A, E, O, U. Can we remember this? I remember when I was teaching at one of the private schools before I came to Unza, I would hear children around singing R, A, E, O, U every day, every morning. Okay, so when you talk of a set of vowels, we are specifically referring to R, A, E, O, U. You can't put W in a set of vowel. It's not a member of this set. Now, we understand the definition of a set. Well defined. Members or elements. This is grade 12 work. Let's go in detail and look at set presentation. Okay, set presentation. Colleagues, pay much attention to whatever I'm teaching you. Pay much attention. So when you talk of set presentation, there are several ways in which sets can be presented. Okay, so I'm just going to say examples of ways in which a set can be presented. And colleagues, these are ways of presenting sets. They are normally related, and I'm going to tell you which one you're supposed to stick to, which one you're supposed to know much. Okay, at Unza, I'll talk much during orientation. At Unza, you don't need to just be intelligent, you need to be smart. You need to stick to what is supposed to be known. So the first way, it is listing. If I give listing, then I'm unfair. The first one is describing. Okay, the first one is what? Describing. The second one is listing. The third one is what? The Venn diagram. Venn diagram. These three, I'll put them in category 1. Understand me well? I want you to understand. This group, I'm going to put them in category what? 1. Why am I putting them in category 1? It's because they are what? They are related. Okay? I'm putting them in the first category because they are related. Let's look at the example for describing. So if I pick describing and I say a set of vowels, okay, a set of vowels. Under listing, I'm capable of listing these sets in this way. This will be, let's assume V as set for vowels is equal to R, A, E, O, and what? And U. So this is listing. Then what about Venn diagram? So for the Venn diagram, it's something that I'm going to show in this particular way. So I'm going to have a rectangular guy outside to represent the universal. So at university, the universal set is represented by E or U. I hope we are moving together. At university, the universal set is represented by E or U. So you need to carefully read the instructions. Then I'll go inside there. I'll put my set V, and set V will have R, A, E, O, and what? U. So these are the members. So if you look at listing, describing, and Venn diagram, these are related, and this is grade what? 12. Do we have any question at this point? Jordan, what's your question? Any question? Any question? Jordan, your hand is up. Okay, Augustino, do you have a question?
Yes, sir.
Alright, Betha, do you have a question? Betha? Alright, good. So this is my category 1, colleagues. Now let's look at category 2. And this category 2 will start from D. The other type is what we are calling the interval notation. Interval notation. So this is the one now that you need to give much attention. No matter what, you need to know it. And there are plenty and plenty of questions about the interval notation. The second one, under this, it is the what? The set builder notation. I remember in grade 11, 10, 12, I used to run away from this guy until I came to university and I was told I have to know it. Set builder notation. The fourth one, which is F, it is the number line. So this hashtag is simply symbolizing a number line. So these are the category 2 and they move together. So the symbols that I use under interval notation, set builder notation, number line, this is something that I'm going to teach in the not next class, after the next class, because the next class I'll be talking about the algebraic laws of sets, which is very important again. Okay, so category 2, it is interval notation, set builder notation, and the number line. All these three are related to each other, and they are the ones that your lecturer wants you to know most. So we'll talk about them later on. So with that being said, we can now go and look at the set notations or set operations. Set operations, which is a very important part, colleagues. So when you talk of set operations, these are just ways in which sets can be described. Remember, when you talk of set presentation, we are talking about describing, we are talking about listing, we are talking about Venn diagram, we are talking about the interval notation, set builder notation, and the number line for your curriculum. But when you talk of set operations, let's say if I say 1 plus 1, okay, 1 plus 1 is equal to 2. So this is a what? A mathematical operation. A plus is a mathematical operation. Let's say I say 2 minus 3, which is negative 1. A minus is a mathematical operation. I hope we are getting the point. So when you talk of set operation, it is trying to describe the relationship between two sets. The relationship between you and I, the relationship which is there is that I'm your tutor, you are my students. That's the relationship. Okay, then when you talk of this guy which I've given, a plus, it's talking about the relationship between you and 1 and 1, 2 and 3. A minus is the operation which is giving the relationship between 2 and 3. Now let's go in detail. So with that being said, we have to understand that set operations are used to relate sets. Okay, set operations are used to describe or illustrate a relationship. The relationship are used to describe or relate the relationship between the given sets. Okay, then there are basically 4 types of set operations. There are four types of set operations. These are: 1, it is the intersection, the same one you are thinking about. It is the intersection set. The second one, which is B, is the union set. The other type, which is C, it is the complementary sets. Complementary sets. Now, this complementary set is the one now which is divided into 2 categories. The first category, okay, remember this is a complementary set, colleagues. This is a complementary set. This complementary set is giving 2 branches: the absolutes and the relative. Okay. Now, when you talk of the intersection set and the union, when you talk of the symbols, I'm just trying to summarize everything, colleagues. So the symbol for intersection is that. The symbol for union is that. And these 2, their symbol is this complement. So those are the symbols that we have to take note. So these set operations, colleagues, they might look as easy as they look, but they are going to demand our attention when we talk about the algebraic laws of sets, when we talk about the interval notation. That's why it's very important for each one of us to put in mind that we have to know these signs. Now, with that being said, let's talk about each one of these guys. Okay, I'll start with which one should I start with? The intersection set. The intersection. Yes, the person with the hand which is up. Yes, Grace.
So I have a question.
Yes.
You said we have 4 types.
Yes.
Then you gave us the first one was intersection, then you have union, and then complementary. But that one is divided into 2.
Yeah.
So when you say the 4 types, do you mean
Yes, I mean absolute, relative, union, and intersection. Alright. And let's not forget that there are also types of set, okay? But all that I'll go a bit in detail with time. Okay. So when you talk of the intersection set, guys, I'm begging you guys to follow up. So the intersection of 2 sets A and B, okay, given the sets A and B, given the sets A and B, their intersection sets, their intersection set is represented as, their intersection is represented as A intersection B. Okay, A intersection B, such that the members or elements in these sets are in both set A and set B. Okay, for example, if we have 2 people like you guys, okay, you and the other person, let's say Angela and Brian. So the intersection between Angela and Brian in this class is that both of them are first years, okay, both of them are freshers. The intersection between you and your boyfriend, you guys who are dating, is that you are going to break up next year. That's the intersection between you two, and you are going to cry. That's the whether you like it or not, you cry, ladies and gentlemen, you cry. That's the intersection between you two. Baradida. Oh, you drink water with the soap. You forget me or water, so had to break much. Carry Papa 02. We move on. Such that was a commercial break. Don't take it too hard, but you cry. So such that this A intersection B is written as brackets, okay, X, such that X is a member of A, okay, such that X is a member of A and X is a member of B. So this is how you present an intersection set, and this and is what is representing intersection. If I present it, this and here, it is the one which is representing what intersection. So wherever you see an and in mathematics, we are talking about what intersection. But with time, we don't even give attention to these guys. Okay. Then, in terms of the Venn diagram presentation, there are two ways or two types of set that you need to know. So if you are talking about the Venn diagram presentation, and what we have is that it is a joint set. Like this is a joint set I. So this is set A, this is the set B. So when you talk of a joint set like this one here, the intersection set is this one which is in between here, your heart, which will be broken. It's what is it in between. Then for the disjoint set, okay, for the disjoint set, I can present it like this. So let's say I have this guy as the set A and this guy as the set B. Okay, I know the screen has stopped showing. Talk of a joint set and the disjoint. So this guy on your right hand side, okay, this guy here, this one, this is a disjoint set. So a disjoint set is a set between two sets that are not meeting together. They are not together. Okay, like you and your bestie, you are not together, you are disjoint sets, just bringing unnecessary drama. You are disjoint set because you are not together. But a joint set is you and your partner, if it exists, and you break up. So break up soon. So for a disjoint set, the intersection A intersection B is equal to an empty set. Empty, nothing is there, and this empty set is either written as those. But for the joint set who are together, they are represented the way I've presented. Colleagues, I'm sure this part is clear. Union set. So when you talk of a union set, let's say you are given, yes, you are free to ask. Rosemary, what's your question?
I don't see anything.
You can't see? Oh, log out and log in. You'll be able to see. From my hand, it's showing.
Alright.
Who else can see? Yes, Olivia. I can't get you.
I'm trying to ask you if you can like do the summary of the class from the beginning, not to that you should compare with things like I was interested in.
Is it okay, because I've covered a lot, is it okay if immediately I finish the class then I send the recording, and then if you have any question you inbox me and I address them? Is it okay, Olivia? Alright. Okay. So when you talk of a union set, okay, so given the sets A and B, the union set which is represented as A union B is made up of, okay, is made up of members belonging to set A or set B. So I've used the word or, such that I've used the word or. So when I use or, for us who went to the private school, we are going to tell you that when I use or, I'm just sticking to members that are in set A or B, and each member should only appear once. Each member should only appear once, meaning that we are removing all the members from the intersection, or members from the intersection should only appear once. Let me present it in this way. So A union B. Yes, the person whose mic is on. Sorry? I don't know if you are asking. Okay. So A union B, this set can be said to be X such that X is a member of A, or X is a member of what? B. So this is how you present it. Or in terms of the number of elements for the union, you're going to say N is equal to A union B, okay, is equal to, you're going to say the number of elements in set A plus, okay, the number of elements in set A plus the number of elements in set B minus, remember what I told you, that the intersection should not be included, so minus the number of elements in A intersection B. So this is another presentation where N is representing what? Number of elements. Number of elements. Venn diagram, remember there are two types of sets. So the first set which we can talk about is a joint set, like this one, which is joint, okay. Then the union, it simply means that you shade everything you shade, and this is set A and this is set B. Then for the disjoint, you're going to have a Venn diagram like this, and this is set A, this is set B, and this is a disjoint. So this is set A, this is set B. So for a disjoint, you are still going to shade everything there, even there, everything like that. Then you have presented what? A union set. Now complement sets, that's where I'll end. The next time I teach you mathematics, I'll be talking about the algebraic closure of sets. Yes, Gerald, what's your question? Gerald? Gerald? Okay. Kapemba. Kumbutso Kapemba.
Couldn't find you. We say like go back to the previous page. I just want to copy something.
Okay, I've gone back.
Thank you.
You're welcome. Is that so you are crying? What could be the problem? Okay. It's normal to click on those emojis. Let's look at the... So for the complement, colleagues, I'm going to summarize for you so that you understand that. So the first one is the relative, isn't it? So the first one, which I said, you have the relative and the absolute. Okay, so you have the relative and the relative complement and the absolute. So I'm just going to give absolute. I'm just going to give the difference because I need to pick one question from the exam, and then we can do it together. So the relative, in terms of the Venn diagram, this is whereby you are comparing two sets. Let's say you have set A. The person who is showing their screen, we can see my love Masala, Joaquin, you have an umbrella, I feel you but need to eat and rest, I just miss you, I'm what? Please. Yes, finally you have moved. By the end of this week, to alarm anything you come on screen now. So this is the relative. Why? So when you talk of a relative, your relative has two parts. So let's say you have set A and set B. So from this, we are just going to compare two sets. Okay? So for the relative, you compare two sets. Let's say you are saying A minus B. So muri A, uchosemo wati, you remove B. Okay? So from that point, if you are trying to shade the set, from A you remove B. So we are just going to shade D like that. So meaning for the relative, you compare two sets. That's for the relative. The other one which we can look at is the absolute. Okay, so this is set A. So the absolute complement, you compare it to the universal set. You compare it to the universal set. So in this case, we are talking about this part. This is the absolute. You are comparing it to the universal set. So it is A complement. So you compare a set to the universal set. A set to a universal set. So that's all about the absolute. This one, I know those who have already studied or are doing A levels somewhere, this one is the same as the A intersection B complement. But for my friends who are just joining for the first time, for this one I'll explain why A minus B is A intersection B complement. We are going to deal with the algebraic laws of what? Of sets. Do we have any question at this point?